Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to our YouTube channel Paper World, where we are solving past paper questions of IGCSE Physics 0625. Today we are solving the paper February-March paper of the year 2005, and the variant is P22. So let's begin. But before we start, kindly like and subscribe the channel, and if you find anything helpful, kindly remember me in your prayers. Thank you. So let's begin. Question number 1. The diagram shows three forces acting on an object. What is the magnitude of the resultant force acting on the object? Okay, now if we look at the image, there are three forces that are acting on this object. So if we try to add these three forces together, so it's going to be a bit difficult. ठीक हो गया? So what we are going to do is that we are going to reduce these forces into two forces. Since these two forces are in the opposite and direction, but they are in the same line, so they can be reduced. So 9 Newton is in the right direction and 1 Newton is in the left direction. So we can make the resultant of these two forces to be 8 Newtons in the right direction. Okay, so once we've done that, we now have two forces. One is the 6 Newton force and the other is a 9 Newton force. Now there are three ways in which you can solve this question. One way is that take some scale, like 1 centimeter is equal to 1 Newton, okay, and make what do you say, a vector. For example, this is 6 centimeters. Okay, so this is 6 Newtons, and you've got your tail to tail method or parallelogram method for the addition of vectors, and you've got head to tail method for that as well. So if you are using tail to tail method, so this is 6 Newtons and supposedly this is 7 Newton, 8 Newtons, which is going to be 8 centimeter. So the resultant is going to be calculated like this. Okay, make this line over here, the same everything, make one over here, and this is going to be your resultant in the middle, and this is going to give you the value. Okay, the other method is that you use head to tail rule. The first vector 6 Newton, second vector from its tail 8 Newtons, and the resultant is going to be from the tail of the first vector to the head of the second vector, and you can calculate this. Same is the case that you've got to take some scale. 1 centimeter is equal to 1 Newton, so this is going to be 6 centimeters and this is going to be 8 centimeters. Okay, so these are the two methods, and the third method that you should do over here is your Pythagoras theorem method. So this is your base, and one of these is your perpendicular, and you've got to find the hypotenuse, right? So perpendicular square plus base square is equal to hypotenuse square. Okay, so your perpendicular can be 6 Newtons or 8 Newtons, doesn't make a difference. So this is 36 and this is 64, and it equals 100, and we need hypotenuse and not hypotenuse square. So in order to get rid of the square, we need a square root. So this is going to come out as 10 Newtons and this is 8, so the resultant is going to be 10 Newtons. So use any one of these methods and you'll get the numbers, right? Moving on to question number 2. Which rows defines speed and velocity? Now speed is a scalar quantity and velocity is a vector quantity. So speed ka formula is speed is equal to distance over time. So distance traveled in a given direction, speed is scalar, so direction doesn't come in that. Okay, speed per unit time this has to have direction. Distance traveled per unit time, yes, this is correct as you can see, but let's look at the counterpart. Speed in a given direction, yes, this is correct as well, because a speed in a particular direction is velocity, since velocity is a vector quantity. So B is our correct option for this as well. Okay, so moving on to question number 3. The graph shows the journey of a motorcyclist. Okay, which section of the graph shows the time when the motorcyclist is stationary at some traffic lights? Okay, this is a speed time graph. In a speed time graph, a straight line like this means that it is moving with a constant speed. So for the part A, it is moving at a constant speed. For part B, it is decelerating. For part C, you can see that its speed is 0. And for part D, he is accelerating again. So we've been asked when he is stationary at some traffic. So C is that portion when he is stationary, because you can see that his speed is 0. So if his speed is 0, he is not moving, he is stationary. ठीक हो गया? Question number 4. The acceleration of the free fall on moon has 1/6 of its value on the earth. On the earth, an astronaut's mass is measured as 60 kgs. Which row gives the mass and weight of the astronaut on earth and on moon as well? Okay, now let's make two tables. Okay, we have the mass of the astronaut on earth, so we can easily calculate his weight on earth by our formula W is equal to mg. So this is 60 into 9.8. So this gives us an answer of 588 newtons. So we are done with his weight on earth. So these two options look viable, but let's go to the moon section and see what is his mass and weight on moon. Okay, now we know for a fact that the mass is the amount of matter in the body, and it does not change, and it does not depend on the gravitational field of the object or the gravitational field of the earth or the planet you are on. So the mass on moon is going to be the same as it is on earth. Okay, but the weight is going to change, because weight is the amount of gravitational force acting on an object. Okay, so we have this formula again. The mass will be the same, but the value of G is, they've told us, 1/6 of the value of that on earth. ठीक हो गया? So what we are going to do is we are going to solve it like this, and we are going to get an answer of 98 newtons, right? So D is going to be our correct option. Mass is same on moon as well as earth. The weight on earth was 588 newtons, and we can make it 590 newtons, and the weight on the moon was 98 newtons, and we found it with the help of this formula. Okay, so moving on to question number 5. The load extension graph for a material is shown. Which point indicates the limit of proportionality? Okay, we know that this question is related to Hooke's law, and the extension and force are directly proportional to each other until the limit of proportionality is reached. Right? We know this concept. So if this is being followed, the graph is going to be a straight line graph, and the point where it starts to curve, that is the point where the limit of proportionality is not being followed. It means that when you take off the load from the spring does not go to its original position. ठीक है, वो ओरिजिनल पोजीशन में वापस नहीं जाता, बल्कि it stays at the same position even after the load has been removed. Okay, so if we look at the graph, we see that a straight line is up until point A, and after point A it starts to curve. This means that the limit of proportionality was reached at point A. Okay, because after this point it's not a straight line graph anymore, it's curving. Okay, so marking point B would be too late because it has started just after A. So A is going to be our correct option and not B. Okay, just keep an eye on these small little facts and you are not going to lose marks. Question number 6. An object of mass 4 kgs is moving with a velocity of 3 meters per second in a straight line. What is the momentum of the object? Okay, momentum is given by the formula P is equal to m into v. So mass is 4 kgs and the velocity is 3 meters per second. So this is going to be 12 kg meter per second. So C is going to be our correct option for this. Moving on. Question number 7. A tall cylinder is partly filled with 2 liquids which do not mix. The 2 liquids have different densities. Obviously, if they are not mixing, they must be having different densities. A student measures the pressure due to the liquids at different depths. Okay. Which graph shows how the liquid pressure varies between the position P and Q? Okay. Now we see that these are the 2 liquids. This liquid P is on the top. That means it has a lesser density than liquid Q. Since it is settled in the bottom, so it has more density. It would be more dense. That is why it's beneath this one. Okay. So obviously pressure in a liquid is depicted by the formula rho GH, where rho is the density, G is the gravitational force field strength value, and H is the height. ठीक है? So more the density, more the pressure. More the gravitational field strength value, more the pressure. More the height, more the pressure. Okay. So once we've visualized this, we can go to the graphs and see that which graph shows how the liquid pressure varies between position P and Q. So this is the position P. Obviously, यहाँ पे the height is very less. The liquid is less dense. So both of these contribute to the fact that the pressure at point P is going to be less and the pressure at point Q is going to be more, since the height is more, since the density of the liquid is more as well. Okay. So if we look at the graphs, we see that the pressure at P is like this. Okay, and the pressure at Q is decreasing. Okay, pressure at P is increasing, and when it reaches Q, though the pressure decreases. Like this is going to be visualized by a simple thing that, for example, you've got a ball over here. So the pressure that this ball faces at is, as it moves down, is that the pressure on the ball keeps on increasing as it moves down, because the height is more over here. Okay, in these points, at these points, sorry, and the density is also getting higher. Okay, so obviously when it moves from point P to Q, the pressure increases, and at Q the pressure increases even more. Okay, so this is going to be it. So this is not the correct option, because you can see that the pressure was increasing, and then while something reached Q, then the pressure started to decrease. So this is not the correct answer. So At P, the pressure was increasing, and as it gradually moved to Q, the pressure kept on increasing and increasing. So yes, this can be an option, but let's look at the other options as well. The pressure and depth are in a straight line. No, this is not correct, because the pressure at P and Q are very different due to their densities and obviously their depth. And pressure being like this, nahi ji, this is also not correct and this is not correct. So B is our correct option, where the pressure from P to Q was being raised, and then it's continuously being raised and being increased. Okay, so B is our correct option over here. Question number 8. A tennis ball with a momentum of 2.3 kgs meter per second is struck by a tennis racket. Okay, the racket causes the direction of the motion of the ball to reverse, and then the racket exerts an average force of 1500 Newton during the impact with the ball. The racket and the ball are in contact with each other for a time of 0.0024 seconds. What is the magnitude of the momentum of the ball as it leaves the tennis racket? Okay. In order to understand all this scenario, what we need is a tennis racket. Okay. Let's suppose this is one. Okay. So there is a ball coming towards the tennis racket with a momentum of 2.3 kg meter per second. Now this ball obviously gets hit by the racket and leaves the racket, and it leaves with some sort of momentum. So let's call this initial and this, let's call this final, and we have to find that. And obviously they've told us that the direction of the motion of the ball reverses. So one of these is going to be negative and one of these is going to be positive, since we know that momentum is a vector quantity and it has magnitude as well as direction. So if it was moving with a certain momentum in a certain direction, and that direction has been reversed, so the momentum is also going to be reversed, the sign is also going to be reversed, and that totally depends on you, that if you take final momentum to be positive or initial momentum to be positive. I always take initial momentum to be positive, yeah, initial velocity to be negative, so that's why I'm doing this. Okay. And the third thing is that this racket basically hits the ball with a 1500 Newton force, and the ball is in contact with the racket for this much time. So what happens is that if you just correlate all of these in an equation, so that is going to be change in momentum, final momentum minus initial momentum, and we know that delta P is impulse, and impulse is force into time. Since force is delta P over T, so this is impulse, and F into T is delta P as well. So let's write F into T over here. Final momentum we are going to find, and we are taking this initial momentum to be negative. So we are going to write this over here. 1500 into 0.0024 is equal to final momentum minus, this is going to become positive 2.3. So this is going to be 3.6 minus 2.3, and this is going to be our final momentum, and it is going to be 1.3 kg meter per second. So A is going to be our correct answer. Hopefully you guys understood the question. Now let's move to the question number 9. Question number 9. A car is traveling at a speed of 8 meter per second. The kinetic energy stored in the car is 32,000 joules. What is the kinetic energy stored in the car when its speed increases to 16 meter per second? Acha. Now what we already know is there is kinetic energy. Okay, the formula for kinetic energy is this. We know that it is 32,000 joules when we have a velocity of 8. So 32,000 into 2 32,000 into 2 is equal to 64, and when all of this divided by 64, the mass comes out to be 1000 kgs. Now we know the mass, so we will take the second situation where the speed has increased to 16 meter per second. So the mass is 1000 and the speed is going to be 16 square. So after solving all this, you get an answer of 128,000 joules. So you can round it off to 30,000 joules. So D is going to be our correct answer. Hopefully you understood the question. This was a pretty straightforward one. Question number 10. The sun is not the primary source of energy for which source? Oil. Oil is a fossil fuel, and sun is a primary source of energy for fossil fuels, because they are made from the remains of animals and plants make their foods from sunlight, and the animals also eat those plants, so there is a chain going on, and the sun is responsible for the source of energy for the fossil fuels. ठीक है जी. The other one is tidal. Tidal basically is dependent on the moon and not on the sun. So this is something, a source of energy in which the sun is not the primary source. Wind is also related to sun, and then wave is also related to sun. So B is going to be our answer, which is a primary source of which is a source of energy, and sun is not its primary source. Question number 11. An experiment is done to compare the rate of conduction of thermal energy in metal and plastic spoons. An ice cube is placed on one end of each spoon and the other end is heated gently. Which row has the correct prediction and correct explanation? Okay. Now, metals conduct heat more readily than non-metals. Metals are good conductors of heat as well as electricity, and non-metals are poor conductors of heat and they don't conduct electricity at all. So the prediction would be that the ice cube would melt more quickly on a metal spoon. Yes. And the explanation for this is that metal is a good conductor. So this seems to be correct. The ice cube would melt quickly on the metal spoon. This is correct. Plastic is a good conductor. This is not correct. Ice cube won't melt quickly on the plastic spoon. So A is going to be our correct answer. We eliminated all the other ones. Okay, question number 12. 4 students determine the efficiency of 4 different electric devices. The teacher knows that one student has made a mistake in the calculation. Which value for the efficiency is not correct? Okay, efficiency can only be 100%, and that too happens in extreme ideal situations. And there are no ideal situation when it comes to machines, because there is some loss of energy in the form of heat or any other form, and the efficiency of no machine can be 100%. Maybe in times to come, they do something, they discover something that makes the efficiency of the machine 100%, but it can't be 100% even in the ideal situations. So one of the student has found out to be not just 100 or 102%. So a machine can never be that much efficient. वो 100 भी नहीं हो सकती, but चलो we say that in ideal situations it can happen. So other values are correct and it can't go beyond 100%. So D is our correct answer for this. Question number 13. A sample of gas is sealed inside a container with a fixed volume. The temperature of the gas is increased. Which statement explains why the pressure of the gas increases? Okay, whenever there is a fixed volume and the temperature has been increased, so the kinetic energy now of the particles is going to increase. When the kinetic energy is going to increase, their momentum is going to increase. When their momentum is going to increase, then they are going to exert more force on the walls of the container, right? So this is the scenario. So let's go through our options. the gas particles collide with the walls of the container more frequently. Okay. The mass of the gas particle increases. No, this is kinetic energy has nothing to do with the mass. The number of gas particles in the container increases. No, this has a fixed volume and no gas is being put in from any other place. So no, this is not correct. The time between collision of the gas particles increases. This is also not correct. I've just told you the kinetic energy increases, the momentum increases, and the force increases. Why does the force increase? Because the particles collide with the walls of the container now more frequently. So A is going to be our correct answer. Question number 14. A student does an experiment to determine the specific heat capacity of a metal block. She records the following measurements: energy supplied, initial temperature, final temperature, mass of the metal block. What is the specific heat capacity of the metal block? So, specific heat capacity can be found using this formula. So we know that actually the answer is in kg degree C. So we need to convert this into kgs. So this divided by 1000 is going to be 0.6 kgs. Okay, and I think this has to be converted into joules, right? So this is going to be 12,000 joules. C idhar aa jayega. The mass is 0.6 and delta T is going to be 45 degrees minus 20 degrees. So 12,000 divided by 0.6, 45 minus 20, is going to give us the specific heat capacity of the block, which comes out to be 800 joules per kg degree C. So D is going to be our correct option. Always look out for the units and always use the correct units in your mind. Moving forward to question number 15. A metal block is left overnight in a cool, shady room. In the morning, the metal block is moved into warm surroundings. Which statement about the metal block is correct in the morning? A. The internal energy of the metal block increases. Okay. The temperature of the metal block decreases. Okay. Convection transfers energy throughout the metal block. D. The metal block contracts slightly. Okay. Now, if we look at the scenario, so what we've been told is that it was left in a cool, shady room. So it was in a cool and a shady room all night, and now it has been moved to a warm surrounding. So when it moves to the warm surrounding, the temperature of the block is going to obviously increase. Okay. So if we look at our options, the internal energy of the metal block increases. What is internal energy? Internal energy is basically the sum of kinetic energy and potential energy. Now this is going to increase because it has been moved. So due to its position, it will increase, and then due to the rise in temperature, because it has moved to the warm surrounding, the kinetic energy of the particles is going to increase. So internal energy in turn is going to increase. So this might be correct. B option states that the temperature of the metal block decreases. So if it has been moved from a cool to a warm surrounding, though the temperature cannot decrease. Convection transfers energy throughout the metal block. This is exactly not the situation we are talking about. And the metal contracts slightly. It might have contracted while it was in a cool and shady room overnight, but once it's moved to a warm surrounding, so it is going to expand when its temperature is going to increase and not contract. So A is going to be our correct option. Question number 16. A fixed mass of gas is contained within a sealed syringe of pressure of 100 kilopascals. The plunger is slowly moved until the pressure is 80 kilopascals. The final volume of the gas is 50 centimeter cube. The temperature of the gas does not change. Okay. So we know that they've asked us for the volume of the gas before the plunger is moved, so the initial volume. So we know the Boyle law is PV is equal to constant, and what we say is P1 V1 is equal to P2 V2. Okay, so pressure 1, actually this is in centimeter cube, so we've got to change these kilopascals, I think, into just pascals. So pressure 1 is 100 and kilo के साथ फिर 3 zeros more, and volume 1 we need to find, and pressure 2 was 80, so this is also kilopascals, so 80,000 pascals, and V2 over here is 50 centimeter cubes. So V1 is going to be 80,000 50 over 100,000. So these are going to go away, and this is going to go away. So this is going to give us an answer of 40 centimeter cube. So the answer to 16 is P. Okay. Question number 17. The diagram shows the more energetic water molecules escaping from the surface of the liquid water. What is the process called? Brownian motion? No. Condensation? No. Condensation though is evaporation? Yes. Because the water molecules, more energetic water molecules escape from the surface of the liquid in evaporation, and it's not conduction. Conduction happens in solids and not liquids. So C is going to be our correct answer. Moving on to question number 18. A hot object emits thermal radiation. Which row describes two changes that both reduce the rate of emission of radiation? Okay, now the rate of emission of radiation depends on the surface area, and it depends on the temperature as well, and it depends on the surface being shiny, and its color as well, whether it's black or white. So it depends on so many things. So here we've been told that it depends on the surface area or the surface temperature. So there is a reduction. So the surface area has to reduce as well as the temperature has to reduce. Both of them are going to reduce, and the rate of emission is going to reduce automatically. Okay. So D is our correct option. Question number 19. The frequency of a wave is doubled. The speed of the wave does not change. What happens to the wavelength of the wave? Okay. V is equal to F lambda. Okay. Where F is the frequency, V is the speed, and lambda being the wavelength. So this is not being changed. The frequency is 2 times now, and the wavelength over here is this. So if we do it like this, so we know that frequency and wavelength are inversely proportional to each other. So if the wavelength is increasing 2 times, the wavelength, the frequency is increasing 2 times, so the wavelength is going to decrease 2 times. Okay? So it is going to be, it becomes 4 times as large. No. 4 times large nahi hogi, large to hogi, it won't be 4 times, it does not change. Nahi, this does not happen because the frequency has changed, so the wavelength is going to change. It doubles. So it doubles? No, because they are inversely proportional to each other, and if one of them is doubled, the other is going to decrease. It halves. Yes, D is our correct option. Question number 20. Which statement about ultrasound is correct? It has a higher frequency than audible sound and is a longitudinal wave. Okay. It is a higher frequency than audible sound. It is a transverse wave. No, it is not a transverse wave. It is lower frequency than the audible sound, and it is of higher frequency. So A is going to be correct, and lower frequency options are not going to be correct. Moving on to question number 21. Which statement about the image produced by a plane mirror is not correct? Okay, the image produced by the plane mirror is virtual, laterally inverted, upright. So any one of these and at the same distance, distance of the object from the mirror and distance of the image from the mirror is same. So any one of these which is not corresponding with these is going to be our correct answer. The image is real? No. The image is virtual. So I think this is our correct answer. The image is upright? Yes, the image is upright. The image is the same size as that of the object. Yes, the size and the distance are the same. So this is correct. The distance from the image to the mirror is the same as the distance from the object to the mirror. This is also correct. So A is something which is not correct. Question number 22. A ray of light is incident on a boundary between air and water. Under which conditions is the ray of light totally internally reflected? Okay, for the light to have total internal reflection, we need two rules. Number one, the light has to enter from a more dense to a less dense medium. And the second rule is that the angle of incidence should be greater than the critical angle. And then only total internal reflection can occur. So let's look at our options. The ray initially in the air is incident on the air-water boundary at an angle of incidence. So over here, the ray is initially in the air. So this is moving from a less dense to a more dense medium. So this cannot just convert into total internal reflection. Okay, the ray initially in the air, again initially in the air, so this is not correct. The ray has to move from a more dense to a less dense medium. Air is less dense and water is more dense. So these two options are not applicable. The ray initially in water, yes, is incident on the water-air boundary at an angle of incidence. Okay. And D, the ray initially in water is incident on the water-air boundary at an angle of incidence greater than the critical angle. So this is the correct option. That satisfies both the rules, both the conditions that lead to total internal reflection. So D is our correct answer. Question number 23. A converging lens is used to make an image on a screen. Okay. What type of image is formed on the screen? Okay, whenever a converging lens is forming an image on the screen, it is going to be inverted, real, and then it could be diminished depending on where it is, or enlarged. Okay, so the type of image formed on the screen is real and inverted. Yes, this is correct. Real and upright, no. Virtual to hota hi nahi hai. Whenever an image is formed on the screen, so it has to be real. So A is going to be our correct option. That satisfies the conditions. Question number 24. A negatively charged rod is brought near to a metal sphere. A positive charge develops on the surface of the metal sphere closest to the negatively charged rod. Why is this? So, if you bring a negatively charged rod closer to a metal sphere, what's going to happen is that the negative charge is going to move away, is going to repel away, whereas the positive charge is not going to move, it's going to be over here scattered more closely to the negatively charged rod. So basically the positive charge doesn't move anywhere, it just accumulates more over here. ठीक है, यहाँ पर भी होगा, but the negative charge is going to move and go towards the other end. It's going to be repelled. So Our option A states that electrons on the sphere are attracted by the negatively charged rod. No, they are not being attracted. Electrons in the sphere are repelled by the negatively charged rod. Yes, this is what's happening over here. Positive charges in the sphere are attracted by the negatively charged rod. Yes, they are attracted, but they don't move when this happens. They just stay where they are. So that is why we don't take option C to be correct. Okay? And positive charges being repelled, so obviously is not correct. Moving on to question number 25. The EMF, electromotive force of a cell, is defined in terms of which quantities? So basically, EMF is the energy transferred by the cell in moving charge around a circuit. This definition is correct. We take EMF, just give me a second, W over Q as well. So it is the energy transferred by the cell when moving a charge around the circuit. Question number 26. A resistor of resistance R is connected to a battery of electromotive force V. There is a current I in the resistor. Power P is dissipated by the resistor. In time T, the energy transferred is E. Which expression is correct? Okay. P is equal to VI. And when it's energy, तो energy is equal to power into time. ठीक है ना? तो power is going to be VI and then energy is going to be T, and power is also V square over R. So V square over RT भी हो सकता है. Power is defined as in terms of another formula as well, but they are not asking about it, so I'm not going to write it. So energy is going to be P VIT. So A is going to be our correct option. ठीक है? Question number 26. Question number 27. A copper wire of length 80 centimeters and a cross-sectional area of 0.20 mm square has a resistance R. Which length of the copper wire of cross-sectional area 0.40 mm square has a resistance R? So, we know that resistance is directly proportional to the length and inversely proportional to the area or the diameter square. So, if the copper wire has a length of 80 centimeters and a cross-sectional area of 0.21 and has a resistance of R, so which length of copper wire of cross-sectional area of this has a resistance R? Cross-sectional area uska, if it's increased to 0.40, so the resistance is going to be R. If now you see that the resistance decreases as the what do you say, cross-sectional area increases, and resistance increases if the length increases. So if the cross-sectional area has increased, so this is going to almost twice, so this is going to decrease by, it is going to get halved. Okay? But if the length is increased, it's doubled, so the resistance is going to stay the same. ठीक है ना? So इसी वजह से the answer is 160. So I hope you understood this, that when first the cross-sectional area was 0.20 and it has been doubled to 0.40, तो the resistance जो है वो half हो गई होगी in this case, R by 2, and we need a resistance of R. So how are we going to get a resistance of R? When the length, which is directly proportional to the resistance, gets doubled as well. So 80 ka double is going to be 80 into 2 is going to be 160. ठीक है? So when this is going to be double, तो यहाँ पे जो half हुआ था वो कट जाएगा 2 by 2 से, and resistance still is going to be R. So that is how we get our answer. Question number 28. Question number 28. 4 identical resistors are connected to a battery as shown. Each resistor has a value of 120 ohms. Resistance R4 is removed. Okay, which effect does removing this resistor have on the effective resistance of the circuit? Okay, the effective resistance does not change. The effective resistance decreases by 20. The effective resistance increases by 20 and the effective resistance decreases by 120 degrees. Achha, there is only one way to find out. Achha, we all know that all these resistors are of 120 ohms. Okay, so let's find the total resistance of the circuit. These three resistors are connected in parallel and one is connected in series. So let's find out the resistance of the whole circuit first. Okay, so 1 by R total is going to be 1 by R2 plus 1 by R3 plus 1 by R4. So we establish a baseline. So this is going to be 1 by 120. So this is going to be 3 by 120 and the total resistance will come out to be 40 ohms of these three resistors, and the total resistance of the circuit now, since now these are connected in series, so we will just add R1 and RT of these three resistors. So this is going to be 40 plus 120. So this gives us a total resistance of 160 ohm when R4 is still connected. Now let's take off the R4 from here and let's now add the resistance of this circuit. So these two resistors are connected in parallel. So inka total is going to be 1 by R2 plus 1 by R3. 1 by 120 and 1 over 120. So this is going to give us 2 over 120 and RT ho jayega hamara 60 ohms, right? So now when this is 60 ohm, the combined resistance of these two parallel resistors, so when we add it to R1, this is going to be 60 plus 120, which is going to be 180 ohms. So when we've removed R4, our resistance, which was 160, has increased by 20 ohms, right? So C option is going to be our correct option for question number 28, right? So I've explained the question in detail. Hopefully you got an idea. Question number 29. The resistors in the circuit shown are identical. Okay. The reading on the voltmeter V2 is 1.5 volts. Over here it's 1.5 volts. The reading on the ammeter A2 is 0.50 amperes. Over here it's 0.50 amperes. And the reading on ammeter A3 is 0.25 amperes. Okay. So what are the readings on ammeter A1 and voltmeter V1? Okay. Now what are we going to do is this is 0.50. So this is going to reach over here. And over here the reading is 0.25. So this is going to get over here in 0.25. So we are going to add 0.50 and 0.25. And obviously na, अब आप देखो ना यहाँ से a certain amount of current was coming in, and it due to this resistor, and over here this resistor, because this all of these components are connected parallel. So in parallel circuit the current total is I1 plus I2 plus I3. So this current was divided over here when it went over here, and some of the current went over here. So this whole current got divided. So when the current passed through this ammeter and this ammeter, and then through this resistors and this voltmeter and everything, so when it reached over here, so यहाँ पर 0.50 was the current, and when this current got over here, so 0.25 was the current. over here. So now when it reaches back, so the current is going to be 0.50 plus 0.25, which is going to give us an answer of 0.7 amperes. So this one is going to have a current of 0.75 amperes. This was the total current that was coming in and got divided, and then obviously when it passed through these components, so it got the same again. अगर आपका यहाँ पे भी ammeter लगा होता तो it would have given you an answer of 0.75 amperes. ठीक है, तो ये तो we found out. तो what's the reading on the voltmeter V1? अच्छा, how are we going to do that? We know that in a parallel circuit, so the V total is going to be V1 is equal to V2 is equal to V3. ठीक है, so what are we going to do is that this one is 1.5, so this one is going to be 1.5, getting 1.5 volt as well, and this one is going to get 1.5 volt as well, since they've told us before that the resistors are all identical. So if this is having a voltage of 1.5 volts, so all of the components are going to have the voltage of 1.5 volts. So the total is going to be 1.5 plus 1.5 plus 1.5. So 3 volts is the total voltage that all the three components are getting. ठीक है, so D is going to be our correct option. Question number 30. A wire is moved in the region between the poles of the magnet. Okay. A current is induced in the wire. In which direction is the wire moved? Whenever there is an induced current, so we always use Fleming's right hand rule, and the direction of the thumb is going to give us the direction in which the wire moves. So if we our first finger is going to point like this, okay, and our second finger is going to point towards us. So if we do this over here, so the thumb points in the downward direction. This is pointing towards us, achha, not in the downward direction. This is pointing in the right direction. So the thumb points in the downward direction. So that is the direction in which the wire moves. ठीक है? So horizontal from the north to the south pole in this direction, no, that is not correct. Horizontal from the south to the north pole in this direction. So yes, this is perpendicular into the plane of the paper. C is our correct option. जब आपका paper आपके सामने पड़ा होगा तो then this is going to be very clear to you guys. ठीक है? Question number 31. Number 31, a fixed resistor is connected to the secondary coil of a step-down transformer. The transformer is 100% efficient. The variable resistor is adjusted so the current in the fixed resistor decreases by 0.25 amperes. What is the change in the current in the primary circuit? Okay, we know that in a step-down transformer, the primary voltage is more than the secondary voltage, and the secondary current is greater than the primary current. So if the current over here has decreased by 2.25 amperes, so we have to see the change of the current in the primary circuit, though it is going to decrease less than 0.25 amperes, because secondary current is already greater than that in the primary coil, so it is going to decrease by a lesser margin than 0.25 amperes. ठीक है? So B is going to be our correct option for this. No change, it decreases more than तो हो ही नहीं सकता, it decreases by 0.25 भी नहीं हो सकता, because the current difference is different. ठीक है ना? ये IS is equal to IP नहीं है, so A option इसलिए ठीक नहीं है, बाकी options भी ठीक नहीं है. The only option that is correct is this, due to this principle. Okay. Moving on to question number 32. An electric device changes the voltage of an electric supply from 240 volts to 20 volts AC. What is this device? Obviously, this would be a transformer, because transformer is used to decrease or increase the voltage of a device that's coming into a device. So it's a voltage, it's a transformer. Question number 33. an AC generator is set up so that its coil of wire is perpendicular to the magnetic field. Okay, the coil of the wire is rotated slowly to produce an alternating current, alternating EMF force. A graph of the induced EMF against time is plotted as the coil rotates. Which section of the graph represents a rotation of 3/4 of a turn? Okay. 3/4 of the turn is going to be, acha, pehle they are telling us that this is over here. The coil is perpendicular to the magnetic field. So this is over here. Then it goes to this point. This is the first one. Then it gets rotated to 180 degrees. And then obviously it gets back to the same position. So OR is the time when when 3/4 of a turn are rotated. This is the first rotation. This is the second, when it is like this straight, and then this gets a 180 degree rotation. So this is C is going to be the point जहाँ पे 3/4 of a turn complete हो गए, and this is a point जहाँ पे फिर 4 turns complete हो जाएंगे, right? So moving on to question number 34. A uranium nucleus 23892 decays to form thorium by emitting alpha particles. Thorium decays to protactinium by emitting a beta particle. Which row gives the atomic number and mass number of this isotope of protactinium? Achaji, when this was converted into thorium by emission of an alpha particle, तो क्या हुआ होगा कि this would have been reduced by 4 and this would have reduced by 2. So this would have given us an answer of 234. This an answer of 90. And when there was a beta emission, so this is going to remain the same and this is going to increase by 1. So this is going to be ये P वाला जो है 234 is going to be the same and this is going to increase by 1, so 91 हो जाएगा. The mass number is going to remain the same and the proton number is going to increase by 1. So this is going to be 234 and 91, so C is going to be our correct answer. Question number 35. Which row shows what happens when the nucleus decays by emitting a beta particle? Change in the nucleus. A neutron changes to a proton and an electron, and finally an electron is emitted. So this is the correct option. So we don't need to go through the other option. A is our correct option. Question number 36. Which precaution does not always reduce a scientist's exposure when working with sources of ionizing radiation? A. Ensuring the scientist only works with a source of radiation that have long half-lives. Okay. Increasing the distance between the scientist and the source of radiation, that won't help. Limiting the time for which the scientist handles the source of radiation, yes, that would help. Placing a lead shield, yes, all these things would help. Ensuring the half-life ज़्यादा हो या कम हो, exposure is not going to reduce, so A is our correct option. Okay, question number 37. A detector is placed near a radioactive isotope and records a count rate of 700 counts per minute. The half-life of the isotope is 8 minutes. The average background count rate is 60 counts per minute. What is the count rate measured by the detector after 16 minutes? So basically after 2 half-lives. So the first thing is, first we are going to subtract the background radiation from the reading. So this is going to give us an answer of 640 counts per minute. So after 8 minutes, this is going to be reduced into half, which is 320. And after another 8 minutes, which is going to give us a time of 16 minutes. So this is going to get halved as well. And this is going to be 160 counts per minute, but we still have to add 60 to it to get the correct answer because we subtracted the background radiation. So 160 plus 60 is going to give us a count rate of 20 counts per minute. So D is going to be our correct option. Okay, moving on to question number 38. A nucleus of an isotope of nitrogen, N, absorbs a neutron. It then decays into an isotope of carbon and emits X. So what is X? So over here, there has been, if you look at this, the nucleon number is the same and the proton number has reduced by 1. So this definitely is not an alpha particle. This definitely is not a beta particle, because if it was an alpha particle, the nucleon number would have reduced by 4 and the proton number would have reduced by 2. And if it was an alpha particle, though, the nucleon number would have remained the same and the proton number would have increased by 1. Okay, so this is not it. And gamma radiations though are not there, so this would have been a proton. So because the proton number has reduced by 1, so this would be a proton. So that is why the proton number is reduced. So D is our correct option. Question number 39. The graph shows how the strength of the Earth's gravitational field varies as the distance from the Earth's surface increases. Yes. Which row describes the effect that this has on the mass and on the weight of the object as it moves further away from the Earth's surface? Okay, the mass will have no effect, whereas the weight, because the mass is the amount of matter in the object, and the amount of matter has nothing to do with the gravitational field strength, whereas the weight is the effect of the gravitational field strength on the object. So if the object is moving away from the surface of the Earth, the gravitational field value would be decreasing, and so the weight is also going to decrease, since weight and gravitational field strength value are directly proportional to each other. The mass will be unchanged and the mass weight of the object is going to decrease. Okay, so C is going to be our correct option. Question number 40. A student plots a graph of the speed of different galaxies moving away from the Earth against their distance from the Earth. Okay, using the best straight line shown on the graph, what is the value of the Hubble's constant h0? Actually, the Hubble's constant is given by a velocity of the receding galaxy to its distance from Earth. So we need to take one value from this line. So this is a very good value because this is corresponds to this, and over this is it. So the velocity is 2 into 10 raised to the power 7, and the distance over here is 1, and they've told us that the distance is distance by 10 raised to the power 25. The distance is going to be 1 into 10 raised to the power 25. Over here the distance is being reduced to this value. So this calculation is going to give us a value of 10 raised to the power minus 18, which is actually the value for the Hubble's constant. So A is going to be our correct option for this. So this brings us to the end of this paper. Best of luck for your studies and see you in another video. Thank you and Allah Hafiz.